matrix, and you basically assign how each resource can access each other resource. So in particular, their processes, and how can the processes access a file? How can the process access other processes? And so you build up this big matrix, and you explicitly define what each thing can do. So it sounds sort of simple, but again, since the system designer does it, it's much more powerful than having a system administrator do it, because you can actually then analyze it and make sure that the that the policy enforces some properties. At the bottom here, where you see type shadow and stuff, this is some examples of the SE Linux policy language. And I don't want to get into details of what the actual language looks like. But basically you declare types. You declare the file type there, says it's a kind of an attribute. This in particular deals with the shadow password file. And then the bottom line is a very simple statement, authorizing everybody that has the authorization attribute access to read the shadow password file. So it's a very simple statement there. So type enforcement basically organizes the entire system into domains. And for each domain, there'll be a set of processes, and those processes can do something that's defined by the domain set up by type enforcement. So a process has a tied-in executable that's tightly associated with it, because that determines what you can do in that domain. So the program is a set of instructions for that. Let me give a more visual thing here. So what type enforcement does basically is take your system, say this abstractly represents your system, and divides it into a bunch of mandatory little cells. It's like the watertight compartments on a submarine, right? So if there's a hole, a puncture in the hull, like the water doesn't spread to all the other compartments. Here, say the puncture would be an attacker coming in, and they get into one domain, like say maybe your sendmail server is sitting over here, and now they can get into that domain, but then the cell-like structure of type enforcement prevents it from spreading, from the attacker from spreading to other things, which is a common thing in the early systems. Sendmail would run as root. Once they got control of sendmail, they could take over the whole system. So on a type enforcement system, there is no root. Now, in reality, you've got this nice sort of clean model where you've got all these cells. But of course, just like a submarine, you have to connect all these dots, right? It isn't, if you had a submarine where all watertight compartments and nothing move between, basically you'd have to go into port to get to the mess hall, right? So what you have to do is you have to carefully, in a real system, is punch holes between all these cells and carefully monitor how you move data between the cells. So like if you had sendmail sitting over here, right? You want the mail to be able to get out of the sendmail domain and go into people's mailboxes. So this is where it becomes sort of a really challenging problem. All right, so let me talk a little bit now about the security engineering with type enforcement. Type enforcement, as I said, is a mandatory policy. And the benefits of a mandatory policy, the main thing, if you look at what they're doing, is a mandatory policy stops a Trojan horse. And I gave a sort of a brief example of that earlier. But that's what you're really trying to prevent here. Because, say a user downloads a program off the internet, they're running it in their environment, and they think it's going to calculate bowling scores or something like that. Well, that program possibly could be doing something else that they don't know. An end user doesn't really know what a program does. So the idea here is with a mandatory policy, we will say we will contain that program so it can only write into that one particular space having to do with bowling scores, say if that was the example. So the idea behind type enforcement is it can constrain and contain code and programs that you don't know a lot about. And that gets you a lot of leverage in stopping all these problems. The other thing that goes on is you can't stop everything, but with type enforcement, you can set up a mandatory least privilege policy. Now, the point of least privilege is you give each program only the permission it needs to do its job and nothing else. That sounds simple, but in reality, a lot of programs, they actually access a lot more resources than they need, or what resources the program needs isn't even well understood. So, but if you think about it, if you have a program like sendmail, there'd be no reason for sendmail to go write the web server. So if you use type enforcement and you take that ability away for the sendmail to write the web server, you've basically shut down a bunch of avenues of attack. And so basically you keep analyzing the system, taking things away that aren't needed, and you've really increased the workload of the attacker trying to break into the system. If you don't have that extra privilege sitting there, you can prevent the system from being abused. You can stop certain classes of abuses. Now, you can't stop everything. But now the bottom line here is this is all great. Everything on this slide is great, but it means that the policy has to be configured correctly. Because if you don't have the policy correct, then maybe SendMail can write to the web server, and then that would be bad. So you have to do an analysis to make sure that that doesn't happen. Now, these next series of slides, I'm going to talk about some of the design patterns when you're engineering a security policy for type enforcement that you have. These are sort of basically the tricks that you have in your bag so that you can apply them to the system and sort of resolve conflicts in ways that actually improve the security of the system. The big thing that type enforcement is good at is these things called assured pipelines. This was done by the original Boebert and Kane paper. Earl Boebert worked at Secure Computing where I worked, and he's the one who came up with type enforcement. And this is one of the prime applications that he came up with, was this idea of a labeler. Now, in the DoD world, right, you got this top secret thing, right? If you want to have a top secret file and you want to send it to the printer, it's very important that when it gets printed out, it says top secret at the top. Otherwise, you could just get past your security problem by printing out a top secret file and saying, oh, it's unclassified, and handing it to somebody, walking it out right out past a security guard or something. So the idea behind the assured pipeline was to set up a series of filters, like A goes into B, that goes into C, and make sure that each stage in this pipeline is executed in order and no stage of the pipeline can be bypassed. So in the example that Boebert used was this labeler example, where you have an application, say it's Microsoft Word, right? Now, you have no chances of assuring Microsoft Word. Or say it's Emacs, right? Emacs, another large program, is going to produce a text file. Because then you can write a very small labeler program, right, that every 66 lines it inserts the label top secret, right? That's a small program. You've got a really good chance of analyzing that and getting it right, that it labels it correctly. Are you going to analyze Emacs and make sure that Emacs can, of the thousands of lines of code in Emacs, you won't know that some other module in Emacs doesn't mess it up. So here you can make a small program and analyze it, make sure it's right. So what the labeler does is it can read the raw data, and then it can move it into the labeled data section. Now the printer driver then can only read labeled data. So here's another problem that exists in a lot of Unix systems, is you have global permission for everybody on the system can read a file. When you have that, you can't do assured pipelines. Because here the printer driver then could then say go read off some file in temp that maybe was improperly labeled and then print that. But with type enforcement, you can constrain the printer driver so that it can only read labeled data. And that's huge for reducing the assurance burden. Because now you don't have to analyze the printer driver code to make sure that it's not going off into the wrong directory. All you have to do is analyze it to make sure that it doesn't mess with the content of the data or remove the labels in some fashion. All right. This is another design pattern. This is probably a much larger design pattern, but I call it buckets. Basically, if you have two buckets of paint, one red and one white, if you want to keep the paints, if you don't want to get pink paint, right, you keep them in two separate buckets and you don't mix the data. On an information security system, what happens invariably is people will say, I've got a computer system, and the computer can keep track of if this molecule is red or if this one is white, and I'll keep them separate in the database. It'll be great. So you basically take the two buckets and you mix it all up. Well, now you have to trust the database or whatever program that's separating the data to make sure it doesn't actually mix the data. So the basic pattern here is if it's important that the data be kept separate, you keep it in two different buckets. And that's a common problem you can apply to lots of different things. And as you see through some of the examples I'll work on later, that basically separation is one of the huge things you try to do to prevent contamination of data as it moves around. The problem is, again, like that system I had with all the cells, right? Though that's a nice picture, but in reality you have to poke lots of holes. So even with simple separation, it doesn't really ever become that simple. There's always something that has to move between, and that's where the interesting analysis comes in. All right. Now, another problem, and this one is sort of difficult to explain, but this is the idea of a subdomain. So if you look on the left there, we have the administrator, right? Say the administrator, he can write those three